Hey everyone, it's Chat here. Today we are tackling the LeetCode problem, House Robber. I'll walk you through how I'd solve this in a coding interview, from understanding the problem and devising a plan to coding, testing for errors and evaluating time and space complexity. I'll be solving in Python and I'll think out loud and ask clarifying questions just like in a real interview scenario. Let's get started. First of all, let me first understand the problem statements. So you're given you're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay, so let me restate the problem. So I'm given actually an array of integers that represents the amount of money of each house. And what we expect to return is the maximum amount of money we can rob tonight without alerting the police. And we know that the police is alerted when we broke. When we break into two adjacent houses. So that's the thing that we have to avoid. Now let's start with the first example given here. So how can we, what's the best option here? So let's say we take 1, then I cannot take 2. I would take 3, and I cannot take 1. So if I take 1, the answer is already determined. The maximum that we can make is, so there are a few things to note here and a few questions I do have. So first of all, can the integers be negative? Because it changes a lot. And we can see here that the nums are all positive. So, and that makes sense because it's all about money, right? So if 1 and 3 are taken, then we get 4. If 1 is not taken, 2 is taken, then 3 cannot be taken, and 1 is the maximum value that we can get, and we end up with 3. Okay, I can see something we can do here that is if I do have one value, let's say the length of nums is 1. If I have only this, well, the maximum that I can get here is actually 1. If I get 1 and 2, I have to make a decision because if I choose the first one, I cannot choose the second one, right? So I would choose the maximum one, that is the second value, so I would take 2. If I have 1, 2, 3, well, it depends actually. Either I take this one and the maximum value is this one plus the array behind it, right? So it's either 3 plus the value of 1, 2, or I actually can do it pretty differently. 1 plus 1, 2, or it would be, so I do not take it. If I take 1, sorry, my bad, it would be 3, etc. Or if I do not take 1, it will be 2, 3. In this case, this is pretty simple. This one gives 4 versus 2, 3, that is, and we just want to take the maximum, right? So I can actually, rather than putting this, I can say maximum between 1. That is 2, 3 is pretty simple. We know that we just take the one with the maximum value, while here, actually what I do is either I take 2 or not. If I take 2, then it's empty, so it's just 2. If I do not take 2, then I end up with 3. So it's maximum of 4. The answer is 4. So how could I solve this? So we want to return the maximum amount of value, money. Let me think about this. So if this one is taken, then it's everything from after. Okay, so I can actually write this down. If nums I is taken, then answer is nums I plus rob nums I plus 2, not I plus 1, plus 2. Else, it's just rob nums I plus 1. And the thing is, as we want to get the maximum amount of money, I don't need this if statement. I can simply have this. I'm just considering the maximum value between this and the other one, right? And there we go. Actually, I could do the same here on the other side. I just want to, invert this. So let's say I'm leaving out the last one, which means that I'm taking -1, right? Sorry, it's n -1, minus I. Oh no, I prefer having this way. It's pretty basic, right? Okay, so I'm always checking into this one, and if not, I'm looking over to the other one, right? I plus 2 and I plus 1. And we know the base cases, right? We know the base cases because we know that if we only have the last one, because we need I plus 1 and I plus 2, can nums be empty? Nums cannot be empty, but it can at least have one, it can be a singleton. So base cases, if we only have one house, then the answer is actually just it. So it's just, nums minus 1, right? Nums minus 1 is the answer. If I do have two values in there, I mean, yeah, if I have two values, 3 and 1, well, in this case, it should be maximum between nums I and minus 2, and nums minus 1, right? This is Rob for when I is equal to n minus 2. When I is equal to n minus 1, we get nums minus 1. And if I is equal to n minus 2, well, in this case, we get maximum between minus 2 and minus 1. And else, we just get maximum between taking nums I and the I plus 2. And yeah, okay. Let's now code this one. Now that we do have a plan for this problem, let me write this down. Carry out the solution. So let's first eliminate the base cases. If length of nums is equal to 1, well, we would return the last one, right? Or the num 0. And if length nums is equal to, I think it's a good idea to actually just have n being let's go with n minus 1. It's 0, right? Let's put this way. And if n is equal to 2, return maximum between nums zero and nums 1. There we go. Okay, let's start with this one. Let me introduce current index. That is gonna be equal to n minus not n minus 1, neither n minus 2, but n minus 3. And what we're doing is while current index is strictly superior to or equal to 0, that is it valid? What I do here is I do have my current index, and I want to have my current value okay, so let me start with n minus 2 actually, as I know that let's go with this one. Not current value, but let's call this prev1 and previous 2. I mean, not previous, sorry. This should be current plus 1, right? Yep. Current plus 1 and current plus 2. Next 1 and next 2, where next 1 is equal to nums minus 2, and next 2 is nums minus 1, right? There we go. And now that I do have this, I know that I have to decrement current index by 1 after every single time. And what I do here is my current value so I will have my so what am I doing here? I can call them first and second, right? Where first is actually it's actually equal to I plus 1, and second is equal to I plus 2, and my current index, so current value is gonna be equal to maximum between nums of current index plus, if current index is taken, then it's second, right? Yes, that's what we can see here. If the current one is taken, we get the second one, and we get the maximum between this one and the first. This is the current value. And now that is done, first becomes the current value. I mean, yeah. and the second one become the first. So second and first are changed, where second becomes first, and first is replaced by its current value. And we do this until the end, and by the end we return first. That is also the current value, but that is only limited to this while loop. Let me now test this with the given example, that is this one. Okay, what happens here? So we get the length of nums. The length of nums is 1, 2, 3, 4, 5. So it's 5. So we get n is equal to 5. Then is it equal to 1? If it was, we would have returned just the first 2. We would have just broken into that house. If it is equal to 2, then we would have chosen between the first one and the second one, depending on their amount of money stashed in there. Now that it is more than that, what we do is we choose n minus 1, n minus 2, n minus 3, that is equal to, as n is equal to 5, minus 3 is 2, 0, 1, 2. So current index is equal to 2. And we get first and second. First is equal to minus 2, minus 1, minus 2, so it's 3. And second is equal to 1 during the first step. And as current index is still superior to 0, we continue. And the current value is computed as maximum of this current index. So 9 plus second, that is 10. 10 compared to 3. So 10 is being kept. Current index is 10. First is being, second becomes current value. No, second becomes first. So second is 3. And first is also current value, right? I could call this temp, actually, but no need. I can rename this for, yeah, no, I can keep this way. What happens next is current value is being, no, it's current index. So it's not 10 here. It is equal to 1. It's being decremented here by the end. And what happens is when we end up to in 1, nums 1 is 7. So 7 plus second is 10, 10, 10, it's 10. So we just choose the maximum, and we end up with current index is equal to 0, first is equal to 10, and second is equal to 10. Yep, and we still continue because we still have the last value, that is 2 here. So current index now becomes minus 1, but we do not care about it. We'll end the loop here. First, that is equal to current value is maximum between 2 plus second, 12, and 10, that is 12. And second becomes first, that is 10. So the answer is 12. And that is exactly what we need to have. Yep. And the time complexity for this one is O of n, because iterating. And the space complexity is O of 1 because we only have simple variables that are being used. Let me run this. Yep, they passed the test. Now let me submit this. So we do have a problem here where the output is 3. Let me run this here. In the case 2, sorry. Let's use this example to improve our algorithm because we do have an error here. So what happens here? So we know that n is equal to 4. Then current index starts at n minus, and we know that n minus 2 is 1 and 2, right? We have 1, 2 for first and second. And what happens next is current index starts at 1. And first is, so we compute the current value that is maximum between 1 plus second, that is 2, 3, versus 2, so it should be 3, and current value becomes first. And first and second becomes okay. Now, so we have 3 and the second is 1, right? The new second is the previous first. So yeah, we end up with this. Then what happens here is we have zero and 2 plus second is 3 and 3 is given, and that is worse. We compare it with, the 3 that we already have, and yeah, so I understand why we got 3 here with my algorithm. Now the expected answer is 4. Let me understand why. So if I take this, oh, there's one thing that I missed. There's one problem with this one. That is, I can make the choice to take this one. Okay, let's say I want this one and this one. So I have to take this one and this one to make 4, right? So I make this choice to take this one, right? But was this choice made? The maximum between, so 2 was taken. We had 3. Okay, if I took this one, Okay. There's one problem with this. That is, so, okay. I was looking from here, right? I was looking from here. If I could take this one, um, let me think about this. So I don't want to, so I had num's current index. That is maybe, for example, here we looked if I'm taking this one with this one, or am I taking this one? And from here, I can make the choice to take this one or this one. Because if I take this one, I cannot take the one after, right? Hmm. Let me put something bigger, 10 and 10, so that we can quickly see these ones. So my initial take was nums I plus 2. Okay. Nums I plus nums I plus 2. Oh, that's right. Exactly. So what happened here? So it was my initial idea was, okay, if I'm taking nums I cannot rob the one after, but I want to rob um, the one after the next one. I cannot take the next one, but I can take the ones after the next. And it made sense actually. If I did not take this one, it was about robbing this one. And this algorithm here is not wrong. What I did with this here is what introduced this bug. So okay. Yes, this is where the problem comes from. I mean, nums second. So the last value is, yes, nums minus 1. But for the first, it's not nums minus 2, but maximum between nums minus 1 and minus 2. That's it. Because for this double, that's what the result is. Let me now take this as a test case and run it to see if this works. Yes, it works. And there we go. That's it. I've solved this problem.